Hi everyone, I'm Sophie. I'm a data scientist at Red Hat, and I'm delighted to be here today hosting this panel on what data mesh means for data scientists. So personally, I'm really interested in how we can make data scientists more effective at their work, make their workflows simpler and more repeatable, and more easily integrated into larger intelligent systems and workflows of larger teams. So I'm delighted to be hosting this panel today, focusing specifically on what data mesh means for data scientists. We've got a star-studded set of panelists with us. We've got Zhamak, who coined the term data mesh. We've got Daniel, who's a Darnett-Canal Professor of Computer Science at the University of Maryland. And we've got Max, who's a Data Engineering Manager at Zalando. So with that brief introduction, I'll let them introduce themselves. Daniel, you want to go first?
Sure, yeah. Sophie mentioned I'm a Darnett-Canal Professor of Computer Science at the University of Maryland. So I both teach both undergrads and graduates there. And I also run a mesh lab there, which you get to play around with data mesh technologies and try and further the vision of the data mesh.
Hi, I'm Max. I've been working as a practitioner in the data space for about 8 years now. And for the last 5.5 years, I had the pleasure of working as first a data engineer and then a data engineering manager at Zalando. And I had the pleasure of essentially starting a data lake at the company from scratch. And while, of course, that all came exciting in bringing all these distributed data systems and also parts of data science journey into the company, of course, I also had the pleasure to experience some of the downsides of working with data in a central way and getting the chance to rethink how data management works as well and how to apply it at company scale. At that time, also, that was actually where I'm very happy that the data mesh concept was also introduced by Zhamak, while we were already thinking about a lot of things to do in that direction as well. And since then, I've been a huge fan of the data mesh paradigm. And I had the pleasure of applying many of these things already in practice. And today, I'm here to share some experiences with you as well on how these things actually worked out and how some practical examples came into place.
Thanks, Max. I think we're all looking forward to hearing about what went well, but also what didn't go so well. That's always what I like to hear, so we can see if we can avoid these pitfalls and know what to look out for if we're going to try it ourselves. And Zhamak?
Hi, everyone. I'm Zhamak. I am the head of emerging technologies at Thoughtworks. We are a global consultancy company. Zalando was one of our clients where, in fact, I had the opportunity to travel to Berlin and give a talk about data mesh about a couple of years back. And what we do really is, what I do at Thoughtworks at the moment is try to refine the concept, implement it for our clients, learn the pitfalls and things we should do and we shouldn't do, and really publish that and share that with the wider industry. So I'm super excited to be here with hear Daniel's perspective from academic and Max's perspective from on the ground, and push the data mesh, I suppose, movement forward.
Awesome. Yeah, I agree. I think we've got a really great group to get look at data mesh from a few different angles today. So hopefully we can explore that more. So first and foremost, we've had already, a day of sessions about data. We've talked about Trino, we've talked about data lakehouse, but perhaps you could step back and give us an overview of what data mesh is. Zhamak, are you up for that?
So what data mesh is really a both technical and organizational approach to managing and accessing data, particularly for analytical use cases. And analytical use cases are fairly diverse, from machine learning, model training, to reporting, to dashboards, and a spectrum of those use cases. I use the term socio-technical because it's not just about the technology, but it's also about how we organize our teams, how do we measure success, as well as how do we create the architecture for managing data. Next slide, please. Well, why data mesh? I think at its core, data mesh tries to address this concern. The fact that we had assumed for almost half a century that for getting value from data, particularly for analytical purposes, when we want to make predictions or we want to discover trends, we have to aggregate and centralize data in one place under the control of one set of technologies or technology stack, and specifically under the control of a centralized team. Despite the fact that data is really coming from very diverse sources, right? We see the proliferation of sources from various touch points, various domains, various products that we have within the boundaries of our organization, across the bounds of our organization. And we have quite ambitious plans on the right-hand side and diverse set of use cases for our data today. We've gone beyond, quarterly or weekly or monthly reports to really embedding intelligence and machine learning into every aspect of our business, in our products, in our services, so that our access model to that data has changed, our expectations has increased, and yet we have to address this kind of the big elephant in the middle, right? A centralized approach, and why now? If you click into the next slide. If you look at the reality of organizations today, so if you're in the bottom axis and the x-axis, you will see the scale of complexity that we see. Our businesses are not single function or two functions. They have various domains and various functions. Each of them are moving at a different pace. We have a kind of the expansion of the sources and diversity of sources. And as we talked about, the proliferation of the use cases. And the approaches that we saw with that we've taken so far with the lake, with the warehouse, generally, this kind of centralized approach, we started seeing around 2018 a plateau of return, a plateau of in value that we're getting from our data. When we look at the investments that companies are making in the data platforms or in the data solutions, compared to investments in, infrastructure and mobile, the return are much lower, right? And time to market is slower, agility is slower. We're seeing the plateau of immunity to change. So constantly things are changing, and our approach to managing data, it's little change upstream can kind of destabilize your pipelines and downstream unhappy Sophies in your organizations because her model is no longer working. We see disparity between the reality of the production data and the data that's been put on the lake for training of the machine learning. So data mesh is really trying to say, let's take this reality, that x-axis, as a starting point, as a default state. This is where we are today. So we need an approach that can let us accelerate and really go beyond the value that we're getting, get more agile in time to market and immunity to change. So that's the why now, I suppose. Next slide, a little bit on the how. I would always like to start with the principles because our practices will evolve and we learn more. But I hope that these principles remain to prove that the kind of the right set of principles over time. The very first one is about breaking down the ownership and also architecture of the data around domains, around how the business decomposes itself, around where the data actually comes from and where the data actually gets used in the business domains, and creating an architecture that supports that distributed model of data ownership and distributed model of data architecture. The second pillar is about focusing on the value of the data to the consumers of the data. So the data is not something that we have to hoard as assets and lock it up into a lake or warehouse. It's really about exposing and sharing the data in a way that delights the experience of data scientists and data analysts. And today we will talk about how would we delight the experience of data scientists, right? And that's a very different perspective in terms of how we structure and share and what sort of affordances we create around the data. It's not just about the data itself. It's about also capabilities such as understandability of the data, explorability, be able to kind of, find it, connect to it, and use it, consume it easily, and most importantly, trust it. So how do we make that data, turn that data into a product? And the third pillar is really about empowering these independent domains to be able to actually create these data products and serve them successfully without needing to hire another 200 data engineers, right? That's just not scalable. So creating new levels of abstraction and self-serve platform, and I'm really excited to hear from Max as what they've done to turn our generalists, experts into people that can generate data products, and also, again, facilitate discoverability and usage of the data products from the consumer side. And finally, with any distributed system, there is always the fear of anarchy. Everybody goes and does its own thing, and data products can connect to each other, and God, what a data mess we will be in. So So the last pillar is really about creating a governance model that keeps not only the domain, gives domains the autonomy to move fast and create data products, but creates a form of governance that the domain or data product owners as the stakeholders are part of this federation of the governance team or federated governance team, and have a stake in implementing cross-functional concerns that need to be globalized. Like, we're going to secure our data products the same way. We're going to have a standardized discovering and describing SLOs. We don't want these sort of, we want to have autonomy, but yet a harmonious and cohesive experience of the mesh, and most importantly, interoperability across the data product. So, and most importantly, we want to really get the human out of the manual kind of processes to make data as a product and make them interoperable through computational policies. So these are the 4 pillars. How does it look like? So in the next slide, I try to give you a little kind of visualization of these pillars in action. So in the bottom layer, you kind of see this idea of the multi-plane data infrastructure. This data infrastructure to bring the mesh to life has a lot of capabilities. So we need to have to somehow wrap our head around different classes of capabilities. So your data platform team is not only now providing your utility tools, the storage, the compute, the workflow management tools or pipeline management tools, but they also provide a new level of experience, a new set of APIs and interfaces for data product developers to be able to manage the lifecycle of data products. So we call that the data product experience plane, and it has a set of APIs and capabilities, as well as a mesh experience plane, be able to now have a set of capabilities to operate the mesh, to discover data products, to connect to them, to observe the lineage, and so on. Your applications, where the data really originates from, they remain to be the same. So you have your operational domain where your legacy system or microservices are running today. The realities are created there, right? But the same team, the same domain is now, you see those kind of oval shape, blue and green representative of the domains. Those domains are now responsible for this new thing we call data product or data product quantum, a new unit of your architecture that encapsulates data, the code that maintains it, and policies that gives access to the data as one unit. And those are now not downstream from a labyrinth of ETL jobs. They're right there next to that operational system, but representing historical, temporal, aggregated view of the data for analytical and machine learning use cases, operated by the same team. And the policies, these global policies that we want to consistently apply to our data product, defined by the governance and enabled by the data product experience plane, really push to the each and every data product, right, as a cross-functional kind of capability. And on the right-hand side, you see the roles of the different teams in this sort of kind of integrated vertical planes. Where does the data scientist fit in this picture? If we move to the next slide. So data scientists today have a relatively fragmented experience, right? You, as a data scientist, if you want to prove a hypothesis or if you want to explore the data, first you have to go and somehow find it. Then you probably don't know if you trust it or not. And very likely you don't trust it, so you have to find the people responsible for it. And then what you do is you say, okay, I found the data. I'm going to bring it under my control and put it in some other store and perhaps create my features and put it in another feature store. And that already created a fragmentation of the reality where the data is and the data that you're keeping for your use case. And then finally, you train your model and deploy it. In the data mesh world, your experience starts with that discoverability. So the number one interaction of a data scientist with a mesh experience plane, it really starts with an ease of easily exploring and discovering. And you might say, well, today I have catalogs and I kind of do the same thing. Yes, you do. This is a little bit more perhaps my dynamic. And most importantly, that number two, you directly, in a peer-to-peer fashion, connect to a data product that is maintained right at the source, but by the people who know that domain, who know that data, and are reflecting that data as it is being operationalized today, right? It's not downstream, again, maintained by someone else, centralized team. And you can peer-to-peer connect to these data products and consume them and run, even in many cases, run your jobs right there on the data product. And when it comes to, let's say you discover it, you can see the documentation, you can see the SLOs maintained, again, by the people who are most capable to maintain that data and know about it. And once you explore it and say, yeah, this is the right thing, I want to train my model, let's say you're using some sort of some sort of supervised learning, then your feature store, in fact, if you decide to have a feature, so you may not need to, because your data product doesn't need cleansing and transformation so much, it's built for you. In case you do need, then your feature store becomes another data product. So inherently, it gets all of those policies applied to it. It gets version. It does have SLOs. It does evolve with the data as it evolves, right? It's not going to be some sort of a stale, static representation of data at a point in time. And once you train your model, then you deploy your model either as an operational system, as a microservice, or as a data product, depending, it's really working as a batch or an online service. And your data, again, your model becomes the code is part of a data product, and again, part of that ecosystem. So we have a more connected world, from going from the systems to generate the data, to the data itself, to the models that get deployed and generate data product.
Before we kick off with the questions, there's just one question from the audience that I want to get to already. So I can't find it anymore. So with that in mind, so Max,
I have a question here. I can read it off if you want. It says, a few years ago, this is from Samir Biko.
Yeah.
He says, a few years ago, my impression was that data mesh was more of a kind of concept or a set of principles. Today, somehow, I think it is advertised more like a suggested approach method for a success with data. Taking into consideration complexity of the data world, how would you categorize data mesh? A framework, principles, methodology, practices, or ...
Yeah, I mean, it is an approach, but happiness, or let's say unhappiness, is in the gap between what we say we are and who we really are, or what we say we do and what we really do. So I don't want to live in that unhappy space. Let's bring the reality and the principles together. I mean, that's the whole point of this, right? If you just want to have a set of principles, well, we can't materialize them. Which job is done? Let's go home. Really, data mesh is an approach. Is, as I said, a socio-technical approach. So it's an architecture and also an organizational structure. You can implement, and it's articulated through a set of principles, because at the time that we created these principles, based on the practice we've done, we thought it's too premature to enforce or prescribe a particular practice. So it's your job to put it into practice. But unless we put it into practice, it's useless. So it's an approach from which you can drive many different ways of implementing the architecture and establishing the practice. Hopefully that answers it.
Fantastic. Thanks, Zhamak. And thanks, Daniel, for finding that specific question that I was looking for. So, Max, Zhamak talked about kind of the pain that data scientists have when they're searching for data and then finding that data and then trying to find out who the subject matter expert is and who owns this data and all of this. And how this leads to sort of this plateau of return where we're not seeing the benefits continue to increase as the data size grows. So is this the pain point that you were seeing yourself in practice? And what else are you seeing as pain points for data scientists around data using perhaps more traditional architectures?
Yes, absolutely. So like a couple of the things that Zhamak already mentioned is exactly hitting the nail on the head in the sense of observing also in everyday practical environments of where data scientists actually suffer the most. Like we all know that data science is not just about like training your model, but it really goes like the end-to-end journey up until the point where you actually bring it to production, but especially also all the way that you actually need to cover up front, which is actually working working with the data that you are using to feed into your models and to train them on top of. And of course, like all these pain points that Zhamak already mentioned in terms of in all the steps like the data discovery, the data exploration, loading the data, transforming the data, cleansing the data, all that has data in it. And that, of course, means the data scientists are suffering as much as anybody else on the analytical space from unclear data ownership and from like bad quality data. And just to like maybe throw in a real life example as well here to reflect a little bit on something that I've actually seen not that long time ago, which was a specific team that wanted to build a new model that were usually working with some data in like a very narrow space, but they were now extending outside of that and needed some new data sources from additional teams that they wanted to work with. It took them a month to even find the data sets that they were originally looking for. And of course, that's like horrible, especially since there was a specific case where the team that they were supposed to get the data from was not even aware anymore that they were actually responsible for that data, because it was a service that was maintained by a colleague that just left the company before. And like these are just everyday cases, and I'm not even diving yet into all the parts of what now happens if my model is actually finally running, and then all of a sudden the source that I'm connecting to is actually breaking. These are all everyday examples of data scientists suffering from bad quality data and from unclear data ownership.
Hey Max, can you? I mean, can you talk a little bit about? I mean, so Zhamak mentioned sort of a big tenet of data mesh is going from centralized governance of data to more distributed governance of data. Can you talk a little bit about how you implement that and sort of why that's been a challenge for you?
Yeah, so it kind of went into two directions, right? The first one is how can you fight these issues of unawareness among data producers? Like how can you really dive deep into the sides of making sure that people are actually aware of the users of the data that they have? And with that, of course, also address all these challenges around like making data actually discoverable, bringing the data in a shape that it's actually specifically targeted for the user group I'm trying to address here. And like exactly those points were like incredibly hard to address also on a company scale. Like you can only imagine, of course, like the teams that are producing these data sets that I now want to start working with. They are, of course, completely overloaded with their own work, right? And like they are usually on a day-to-day basis facing the same situations that they don't even have the time to take care of these things. And it was incredibly hard to break that loop. It was incredibly hard to like dive into the single team use cases and really start small and like break that loop in the sense that we are trying to help them take more ownership, take more responsibility for the data, have more awareness that there are actually users out there that need their help. But also to then scale this on the company side and get the buy-in from the management to free up some additional resources to actually address these things. Also by, for instance, providing a new data engineer for the source team that can then help me to actually get there.
But what about things like sorry, I mean, maybe I should stop, but I just
no, go for it. This is great.
Just like what about things like policies? Like let's say policies about like quality of data or policies about how well integrated data is with other data sets. So sort of like policies that need to be sort of global across the organization. How do you guys do that in practice?
Mm-hmm, mm-hmm. So one of the important points is exactly what Zhamak also mentioned before, that you, of course, need to guarantee that you can make local decisions by yourself, but that you also don't run into the situation where everybody is building their own new silo, right? And like this is, again, a point where, of course, we are trying to decentralize and we're trying to parallelize as well to be able to scale and to solve these bottleneck situations. But at the same time, there has always to be a certain point of synchronization also, so that you actually understand what the people need and what are the next things that you should build. And this went into several directions, because on the one hand side, we were of course trying to connect the different data product owners with each other, so that you could actually come up with some global best practices in the sense of where should I actually put my data when I want to share it, but to also bring in the perspective of the platform teams. One of the experiences that I've been through a lot of actually understanding what are the capabilities now needed to support them. Do I need some compute infrastructure? Do I need a storage layer? Do I need a data catalog where I can actually start from the very first step with discoveries and descriptions of the data and even connect these teams? And then, of course, like bring in the end users to understand their perspective in the sense of what is it actually that helps them, right? What are their biggest pain points, again, similar to some of the things that I mentioned before, to get to the point that we can address those and provide on the one hand side the capabilities, but on the other side also the structure for the producers, so that they can follow some standardized approaches on this.
Right. And so, Zhamak, is that in line with what you've seen with your clients as well, and the kind of the flow that they've been on this journey?
Yeah, I think going back to kind of the frictions and the pain points, right? There are always the two friction point that we see with our clients and working with data scientists. One is, give me the data. They're always ahead of the data, as in their aspirations and the models they want to train is stuck because we don't have the data, right? Or we have it, it's out of date, or we have it, but we can't trust it. So accessibility and be able to really peer-to-peer, and again, I emphasize the point peer-to-peer because instead of waiting for someone else to get the data to you, you can directly go to the source that now is accountable to serve you as a customer, as a user, right? The e-commerce team, the order management team, like those folks are now responsible to serve you this as an internal customer for the analytical data the same way that they were responsible for, their e-commerce application. So to really remove that lag in between and get them, so remove that friction point. So that's, we really, with our clients, emphasize on the persona of a data scientist and persona of data analysts as the consumers when we build the data products early on to make sure we address their needs. The second point of frustration and the friction for data scientists is that, okay, I've trained my model based on the sample data that I had. I put it into production. It's the disparity between the reality of what data is in production and the data that I got trained with is actually throwing my model off, and it's not performing as I expected, right? So again, that's the result of centralizing data and transforming and converting and putting somewhere that has decayed and it no longer actually represent what happened in reality. So training your models with the data, again, coming directly from the domains, yes, it has been cleansed, it has been transformed to be able to model the data. It removes that disparity problem that you see at the end. And we have always heard this, like 60%, 80%, whatever percent of the data scientist job goes into cleansing and transforming. None of that is possible because it is needed anymore, because, well, majority of it, not none of it, but majority of it won't be needed because it is now the job of the upstream to give you data that is cleansed, that you can trust. And yes, you may want to transform it. Yes, they give you audio file and you need to transform it into, I don't know, text or do sentiment analysis and create new set of data. That's part of your job. But no longer those wrangling and cleansing task is part of a data scientist job. And that's kind of the journey that we try to, the perspective that we bring to our clients, and then they go through the journey of data scientists to see how they can remove these friction points.
Right. And I think that wrangling and cleansing, which we end up spending the most of our time on as data scientists, I think I'm going to throw it out there and say none of us enjoy it. It's not what we want to be doing with our time. So, we've got this kind of notion that, okay, the data scientist is now going to discover who owns the data, connect to that data right at the source as a product, understand it, consume it, and they might even run their analysis with the data right there. So for data scientists, no more wrangling, no more messing around, no more running around saying what's this, what's feature 7, what's happening here. So Daniel, does data mesh solve all of data scientists' problems? Do you think we're done now?
Well, I mean, I think from what I heard from Max just a few minutes ago, we're clearly not done, right? So I mean, he used the keyword as a synchronization point between teams, which which sounds fine, but in practice, sort of that's like a swear word in parallel computing, right? So, I mean, that's a little extreme, but what I'm saying is that in general, when we want to make things as parallel as possible in computer science, what you do, you want to make sure there's no coordination whatsoever, right? So you have whether you're dealing with one machine, you have a bunch of different threads in the machine, or whether you're dealing with a bunch of machines, you have data partitioned across the machines. But either way, you want to have each processing unit be independent from all other processing units. So if you have a goal you're trying to accomplish, you want to sort of divide that work across all the processing units and have them all run independently. And ideally speaking, data mesh, relative to what we had before, it should be the same thing, right? So you have these sort of teams of domain experts which are managing data. And to the maximum extent possible, you want to ensure that they're operating independently, they can get that job done without too much interaction, coordination with the other teams. So, I think that to answer your question, Sophie, really, there are some things that are very hard to do in a distributed fashion, right? And as I've alluded to already in my question to Max, which when it comes to governance and data integration, sort of like I don't know any government in the world where it's not centralized, right? So you have one leader and you have a team, you have some sort of House of Representatives or some team of people which are sort of managing everything. And so that word governance, and we think of that as being a centralized process. So doing that in a distributed fashion and also data integration, right? So as Zhamak mentioned, that you need to have data clean before we get to it as data scientists. And that's of course true, but what does clean even mean, right? So there has to be some sort of definition of what it means for data to be clean, and that may sort of change across different use cases, but also just as an organization in general, like what is clean enough, right? I mean, there's always it's a spectrum, and so we have to have some sort of standards across the organization, and figuring that out without sort of too much centralization is non-trivial. And so as a researcher, and what I do in my lab is sort of those types of questions. There's plenty of room to work there. As there's plenty of things for me to do as a researcher to sort of think about how we can work on really going to the full vision of the data mesh and having everything be in as distributed as possible.
I want to double click on what Daniel said there about what does even, let's take that example, because this is just such a brilliant example. What does clean even mean, right? How much do we need to standardize through our kind of global policies, and how much we need to allow to diversify, right? So, and I think that the beauty of distributed systems is that you have an axis around which you can extend and scale out, right? Even a problem as kind of cleansing data. So you might say that the data product that, okay, so we will have as a standardized articulation, the SLOs that describe the quality of the data. We all agree what sort of SLOs do we need to describe the data with, right? And then you might say that, okay, this native data product that is getting the events from right at the source from the system, and it's just providing those events, an infinite log of those events, is guaranteeing an SLO, a cleansed data that has high frequency, near real time, but perhaps slightly lower integrity. There might be some missing events, not consolidated, and data is not consolidated so much. That's one data product. It's probably okay for some use cases. But at the same time, now we have a possibility of having another data product that consumes that data and says, in fact, I want that my SLO has lower real-timeness, so there is a lag, there's a skew between the processing time and the event time, but I will have higher degree of integrity because I will consolidate the things that happened later, and I can create a more higher quality picture of what happened, right? So, but the governance needs to just articulate what are the SLOs and how do we codify them. And Max's team goes off and builds a platform to codify and embed those into every data product. And it's now the job of the domain team to expose that information. And it's really the choice of the data scientist and consumer to say which one I'm going to pick. And if none of this fits me, I'll create a new one that actually fits me, right?
I love that you actually brought up this point around the infrastructure way of influencing these topics as well to lead towards standards by providing a platform. Because I would like to also use this as an example to showcase a little bit that central does not always mean bad, right? Because just to throw out another example, we once had a situation where we had I think around 50 teams that were working on data science use cases, and all of them were operating their own infrastructure, which is of course a pretty horrible situation because probably once every other week, you're introducing another team, another use case, where the first thing that happens is a new data scientist is hired, and they spend the first weeks and months of their job in the new team by learning how to operate an infrastructure, and then probably not even doing a good job at that because it's simply not their core competency. And we also went through this process of understanding that this is a particular capability that should be operated by a central platform, that should be taken in, and that should be simply operated and given out as a capability to those teams. And we actually set up a central team that then started operating Spark infrastructure for all these data science use cases. By now, we have a team that is operating with 3 engineers and actually used by more than 100 teams across the company that are providing the Spark infrastructure. And on the one hand side, this is serving the data scientists incredibly well because, again, they save so much time by not needing to care about the infrastructure. But on the other side, it also brought us into the position that we made it extremely simple to get your infrastructure. We just ask you for a template for some basic information about, I don't know, who needs access to which kind of data and these kind of things. And then the central team took care of that without needing to understand your particular use case. So they actually stayed data agnostic. They were no longer the bottleneck in the sense of providing something that they need to learn about the content and the domain that you're actually working with, but they just provide you the infrastructure, and then what you actually do with it, that's totally up to you.
Right, fantastic. That sounds like I don't know. It sounds great as a data scientist, knowing someone else is managing all my Spark stuff, and they're going to be the pros at this. This sounds really positive. So just before we wrap up, I've got one sort of really nice higher level question in the chat here. So Samir is asking, what is the relationship between data mesh and business goals? How are we aligning data mesh and the stepping back and thinking as a business, I want to solve this problem? Zhamak, do you want to speak to that?
I can have a go, but I'm curious to see what Daniel and Max, how do they articulate this. But I mean, if you look at your business goals today, I talk to a lot of, kind of CTOs, CIOs, CSOs, and CDOs, in fact. And what you see is that there are on your many organizations a strategic roadmap. There are a set of initiatives that depend on the data, depend on applying the data and using it in intelligent ways. Augment your product, augment your services, optimize your workforce, whatever it is. So as a starting point, your business is dependent on data to achieve its goals. So where data mesh comes to play, data mesh is an enabler for those goals. It's not the goal itself. The business goal is not, I'm going to go build data mesh, but it's an enabler. And how does it enable you? It enables you by reducing friction and lead time to access to data so that you can achieve those goals. It helps you by really, I don't want to use this word democratization. I wish there was another word because it's just so abused and cliche, but it really tries to democratize and free and unlock the data that are within the domain. So it removes friction, helps you go faster to reach those goals, and also allowing you to experiment, to ditch the goals that are the experiments that are not gonna get you to those goals instead of spending months and months and months and then realize, oh, there was actually no value insight in this data set that we had. So it allows you to run a business that is intrinsically and experimental based, right? Be able to experiment with hypotheses rather than, plan and commit a giant budgets to go and now be able to kind of prove or disprove your hypothesis, because this sort of ML projects are very costly today.
Right. Okay, so in the last couple of minutes, let's wrap up by thinking about data scientists. So as a data scientist, what do I and the audience need to go and do in order to become successful with data mesh? What do you think we need to focus on to make us better data scientists in the data sense of the word? How can we prepare for the changes that are coming? And where should we go to find out more? Daniel, you want to start?
Sure. So yeah, I mean, because it's kind of a packed question there, a lot of pieces to it. I would point out a few things. It's also just sort of to mention something from the last question too, which Samir asked. I think one other sort of business side of this that we need to consider is that a business, one side effect of the data mesh, besides it being an enabler, which is very important. Of course, the main reason why data mesh is to enable better data analysis. But the other piece of it is that these data products that these domain experts create are not necessarily have to be local, right? So it's theoretically possible that the data products that a particular team creates is relevant to other people outside the organization and can be monetized as an independent data product for the business. So it's sort of, in some cases, the data mesh and the methodology of data mesh can actually expand the scope of the utility of data to beyond an organization, and also provide new streams of revenue for the organization. So where this comes back to data scientists is that the data scientist, really what they're doing is they're adding value to data, right? They have some input data and they're running some processes on it in a pipeline, and output is usually some other data set. And that data set, at this point is no longer a local thing, right? So sort of now, it's you were asked to do this by some you were tasked for this particular task by some small group of people, but at the end of the day, this thing that you produced could be relevant to people within throughout the whole organization, even beyond the organization as well. And so we have to start thinking about what it means. I have a responsibility now when I create data. I have to now really think about using global identifiers. So how do I put the data in context of the global metadata that we have in the organization? How do I think about integrating it with existing data sets? How do I make sure that it's clean enough, after doing everything I did to it, it's clean enough for other people to use, it's documented enough, it's sort of clearly cataloged and made available to the rest of the organization, the rest of the world. All these things are sort of, we have more responsibility now when we create new data sets to make sure they're consumable by other people, both internally and also externally. Right. So I think that's an important thing to consider. I better stop since we're running out of time, but also, there's much more that can be said here.
Max, based on your experience, what do data scientists need to do, be prepared for going forward?
Yeah, I think the most important parts is already just doubling down on what Daniel already said, in the sense that you need to now be the next one to carry the torch. You need to start adopting and thinking about some of these things that the data mesh is also proposing. Once you are in this position that you get much better data input, you need to realize that what you are producing is, again, something that is actually serving a purpose that can by far extend just the scope of your team. So now you are the next one to actually carry over the benefits of the data mesh. You now need to work on better project structures, visibility, resilience, all these kind of things when it comes to the outputs that you're actually producing. Because after all, you're in the end now the one that is actually enabling the next people that come after you.
Thanks, Max. Zhamak, any final words?
Well, these were wonderful, I think, comments. I think that the one theme is clear from both comments, that you are part of the mesh. You're not separate. You're part of the mesh. You're consuming it. You're also producing data products as part of the mesh. The other thing I would say is that let's reset expectations. It's not your job to cleanse somebody else's data. It's not your job to decipher what this data really meant. It's the producer's responsibility. We're flipping the responsibility. Producers should give you, you are the consumer. You are the customer. So delighting your experience matters. That's why it's called the data product. So your expectations should be from the data products that are being served to you, to have all the information you need to really go from a hypothesis to find the data, to use it in a span of hours, not in a span of days or maybe minutes, right? So reduce that lead time and friction.
Perfect time to tell everybody that Zhamak is writing a book on data mesh, delivering data-driven value at scale. And you can go ahead and download the pre-release chapters for free at this address here. So we'll leave that up for another couple of minutes. Team, thank you so much for the discussion today.